Alright, so we're going to be talking about SUVAT equations. It's not equations, there's no R in the word equation. Alright, so let's go back to what the definition of acceleration. Now, acceleration is the rate of change of velocity. Now, we remember that velocity is a vector. So let me just write down what the equation is. So acceleration is equal to the change in velocity divided by time, or change in speed. Well, just remember that speed is a scalar and vector is velocity is a vector. So I'm just using speed and velocity interchangeably for the time being. So A is the symbol for acceleration, V is final speed, U is initial speed, and T is time taken. Okay, so let me just write down this equation to the left, just to remind ourselves, and I'm just going to rub off what's on the right hand side. Right, so for the next bit, we're going to have to use some graphical or some diagram, a diagram method. So we're going to draw a graph of velocity against time. So the y-axis is velocity and the x-axis is time, and here what it shows is that it is accelerating. So its speed initially is u and its final speed is v. So that's why you have a slope. You have a straight line at an angle, not horizontal, so you've got a diagonal line starting from u, initial speed, and ending up at v. Now the area under this graph will be the displacement. Because what happens when you times speed with time? Speed is equal to distance divided by time. So distance is equal to speed times time. So the area will have the units of velocity times time, and that would be displacement or distance. For the moment, I'm just going to use them interchangeably. So displacement is a vector and distance is a scalar. So what is the equation for trapezium? It is half brackets a plus b times h, where a and b are the parallel sides of the trapezium and h is the distance between those two parallel sides. So u and v is the a and b, where u and v are the parallel sides. Okay, so a in this case is u, b is v in this case. So let me just write this down. So the displacement is equal to half brackets u plus v close brackets h. So displacement is equal to half open brackets u plus v close brackets, and in this case h is t. So displacement is equal to half u plus v times t. So let me just rub that out and then put the equation on the left hand side. So now you've got two equations, one for acceleration and one for displacement. Now to get the SUVAT equations, you need to combine those two equations together. Now what's the symbol for displacement? It is S. So S is equal to half open brackets u plus v close brackets times t. So to get the SUVAT equations, we just have to combine those two equations together. So we're going to change the subject to v. So rearranging for v, if I times both sides by t, t on the right hand side will go, so you're left with at is equal to v minus u, and then because you've got the minus u at the top, I'm adding u both sides, so v is equal to u plus at, and then I'm going to substitute the v into the trapezium equation. So what happens when I put them in? So S is equal to half open brackets u plus, now I'm just going to substitute the v inside. So you know that v is equal to u plus at, so I'm going to substitute into it. So u plus brackets u plus at close brackets, times t. I can simplify the u and u plus at together into 2u plus at, close brackets t. I'm going to multiply the half and the 2u plus at, so that ends with, what's half times 2? 1. So u plus half at, close brackets, times t, and that's s, and then multiply all that out together, you end up with s is equal to ut plus half at squared, and this is one of the SUVAT equations. So I'm going to put this equation on the left hand side. Now the next equation, if you've done triple science, you would have come across this equation before. This is v squared minus u squared equals 2as. Okay, so how did we derive v squared minus u squared equals 2as? So we need to get rid of t. So we're going to change the subject to t. So t is equal to v minus u divided by a. And then I'm going to put that t into the trapezium equation. So substitute the t into that equation. So s is equal to half brackets u plus v, close brackets, and then v minus u times a. Now there's something that you should recognize. V plus u times v minus a, you have difference of 2 squares. I'm just going to swap the u plus v into v plus u. They're basically the same. For scalar, a plus b is the same as b plus a. So what happens when you times them together? So v plus u times v minus u is equal to v squared minus u squared. The a remains at the bottom and 2 goes at the bottom. Now I'm going to multiply both sides by 2a. You end up with 2as is equal to v squared minus u squared, and then rearrange to get v squared. So v squared is equal to u squared plus 2as. Now for the next part here, how do you get s is equal to vt, not u? How do you get s is equal to vt minus half at squared? So remember we worked out the area under this graph as a trapezium. So the trapezium is working out the area of that shape. Now another way of working out the area under that graph is to have a rectangle minus the triangle. So can you see that triangle there? I'm just going to label the v and u. So the trapezium, using the trapezium, you get s is equal to half open brackets u plus v, close brackets t. So another way is to visualize it is to have a rectangle minus the triangle. Now what is the area of that triangle? Sorry, what is the area of the rectangle? The area of the rectangle is the height of that rectangle times the width. So in this case is vt. What is the area of the triangle? So you want to work out half times base times height. So the base would be, well, if you know the height is v and you know it's u at the start, you will have v minus u. So the whole thing is, the whole height is v, and you know that at the beginning is u. So you know that that small distance, the base is v minus u, and what is the height? It's t. So the area of the triangle is half v minus u times t. So we're going to put them all together. So displacement s is equal to the rectangle minus the triangle. So that's vt minus half v minus u times t. There's a clever trick coming up now. We're going to we're going to write down the equation for acceleration. So acceleration is equal to, remember what is it? It is v minus u divided by t. Now look, the v minus u over t looks like it looks quite similar to half v minus u times t. How can we make that to that? Okay, so the symbol for acceleration is a. So a is equal to v minus u over t. What happens if we times everything by half? So half a is equal to half v minus u divided by t, because what you do to one side, you have to do to the other side. But there's a t there, and in that one you got over t. So how do you get over t into just t? Well, you have to times by t squared to get rid of that t at the bottom. So half at squared is equal to half v minus u over t times t squared. What is 1 over t times t squared? Just t. So half brackets v minus u brackets t. And that looks exactly like that. So substitute that into there, you end up with s is equal to vt minus half v minus u times t. So let's just write all the equations down together. So s is equal to vt minus half at squared, or s is equal to ut plus half at squared. V squared minus u squared equals 2as. Acceleration, the equation of acceleration, a equals v minus u divided by t, and the trapezium rule, just the trapezium equation, s equals to half u plus v times t.